the name of God. Hello and welcome. In this video lecture, I would like to make a short discussion on different kinds of uh, transformation from ABC to DQ0 reference frame. Of course, as I will mention later, the arrangement of D, Q, and 0 can interchange. For example, it could be Q, D0, etc. There are various kinds of transformations in different papers or in different textbooks, and you will encounter some problems when you are comparing different formula in different books. I would like to discuss what can be the reason for the difference between the formulas in different papers on different textbooks. The reason is we have several versions of ABC to the arbitrary reference frame transformation. And the causes for this difference are, so let me write. There are several reasons for difference in transformation matrices and the result is in the equations and machine equations. This is matrices, let me correct it. And the machine equations, although the machine is the same, but the mathematical relations seem different. In different papers or textbooks. This is interesting, really interesting. I would like to tell you that there are several reasons that you should consider when comparing the equations of an identical machine in two papers or in two textbooks. The reasons are as follows. The transformation can be amplitude invariant. I will explain. Amplitude invariant or power invariant. Of course, we can have transformations which are neither amplitude invariant nor power invariant, but this is not typical to use such a transformation. And for a three-phase to arbitrary reference frame transformation, or you can say 3-to-2 transformation, you cannot have a transformation which is both amplitude invariant and power invariant. Of course, for two-phase systems, you can have transformation which is both amplitude and power invariant. But for three-phase systems, maximum of one of these two specifications you can have, either amplitude or power invariant. So one of the causes that you see different transformation matrices is this. The transformation can be amplitude invariant or power invariant. Amplitude invariant means for the very special case that you have ABC variables, a steady state, sinusoidal, balanced, positive sequence quantities, then they will be transformed to a steady state, two-phase, balanced, sinusoidal quantities with the same amplitude as the original three-phase quantities. Of course, there is one exception, that the two-phase transform variables are not sinusoidal, and that is the synchronous reference frame. But in the synchronous reference frame also, the amplitude invariancy has a meaning, that is root of the d-axis component squared plus q-axis component squared equals the amplitude of the original three-phase variables. So this is one of the reasons that you can have different transformations and different formula in different papers. The second reason is q-axis can lead d-axis or vice versa. Of course, it is more common to consider that q-axis leads the d-axis, lead in the direction of the rotation. But some of the old references, such as the book by Professor Anderson and Ford, or by the book by Professor Bergen, consider the q-axis lagging 90 degrees in space, the d-axis. So this is another reason that you can encounter different transformation matrices and different formulas. Let me change the color. The other one is definition of transformation angle, of the transformation angle, theta. You can define the transformation angle to be the angle of the, let me draw something here, and let me use different colors to avoid becoming tedious. This can be the case. Let me here. This can be theta, or this can be defined as theta. So please take into account that theta is the angle of one axis with respect to the A phase axis, not the angle between two axes. This is different, because here the theta, the angle, has a sign. It can be positive or negative. For example, this theta is plus 30 degrees, but if it was here, this theta, then it would be minus 30 degrees. So this is a directional angle. Please take it into account. This is important. Directional angle. So angle of d axis or q axis with respect to a phase stator axis. So one other cause that you encounter different transformations, different formula, is that some textbooks consider theta as the angle of q axis with respect to a axis, while others consider the angle of the d axis with respect to a phase as the angle of transformation, that is theta. So this is also another cause that can lead to confusion if you do not consider this. Another point which can lead to different matrices for the transformation is that if you are bringing the elements in this manner, dq0 in this manner, or qd0, or 0 dq. Of course, you can have 6 patterns, 3 factorial, but these 3 are the most common. In the book by Professor Bimbahara, you have dq0. In the book by Professor Krauss and Chimun Ung, you have QD0 or QD0, let me say. And in some old books, like the book by Professor Berger, you have 0DQ. I hope it has been a good introduction, and I will continue, God willing, on this topic more in the next clips. Thank you very much.